I'm Anil Kumar. Here is a review on equations of lines in R2. That means 2 dimensions, 2 space. We'll see different forms of writing equation of the same line. Let us take a point P. Let's say the point is minus 2 minus 1, okay, and let's take direction of the line to be as 3, 2, okay. Let this be the direction of a line. So we'll write different forms of equations for this condition where a point is given to us and the direction is given to us. So first let me sketch and then we'll write down different equations. Okay, so let me draw this as my y-axis, and here we'll take the x-axis. Okay. So we'll begin with the original point P, which is minus 2, minus 1. So minus 2, minus 1 is this point. So that becomes the point P. And from here, the direction is 3, 2. That means 1, 2, 3, 1, 2. So that's the second point. So we can do 1, 2, 3, 1, 2. And likewise, we can get other points for the given line, right? Joining these points, we get a line. So that is how you can sketch your line from the given conditions, which in our case is a point and direction vector. So in this particular case, we are given a point and a direction vector. Well, some of you are very familiar with another related term, which is slope. Now, I'll avoid slope since slope is not, I should say, meaningful in 3 space or R3, in R3, okay, because slope is rise over run. That means we're talking about 2 space. Rise is along y, run is along x. But if we have R3, then how will you define slope? So it loses its meaning. Direction is a better word. So direction vector is what you should be using. So I'll try to avoid M for slope and use D for direction. Okay. Now once we have a point and a direction, we can always write the vector equation. So we'll begin with vector equation. So vector equation is the set of points on this line could be very easily found if we begin with point P, which was minus 2, minus 1, and add multiples of this point, the direction, right? So those multiples are represented by a parameter, which normally we take T as the letter. You're free to choose other lowercase alphabets. Okay, so 3, 2, right? So these are multiples of your direction. So they give you different points. Now where T belongs to set of real numbers. It could be positive, negative, decimal, fractions, whatever. Okay. So that is how you get very simple equations. So this is what it is. Now here, minus 2, minus 1 is the position vector, which we will say from origin to this. So that's the position vector, right? So at times we'll represent it by an arrow like this, right? So this is OP, right? So that's the position vector. The other point here is if I add minus 2 to 3, I get 1. That's the x coordinate, 1. And the y value, if I add minus 1 to 2, I get again 1, so 1, 1. So this is for t equals to, this point is for t equals to 1. Do you see that? So if t equals to 2, then I get the next point just by adding these vectors. Right, so I hope you get the idea, right? So at times what we do here is, to get the second point, we say, well, this is my second position vector. Joining these two and extending gives us the line, right? So set of points along this direction is what we are saying, correct? So OP is our original vector. We say R0, and this we normally say S, which is t times the direction. Do you see? T times the direction. So this is the vector S, t times the direction, and that's the resultant R. This is this xy. So we get the point xy, coordinates of this point, by adding these two vectors. I hope you get the concept, right? So that's the concept. So I could get more points by adding these 2 points. So that's what it is, and this is called the vector equation. Now here, as we had been talking about, these are your x points, these are your y parts. So we could have written this equation as x equals to minus 2 plus 3t, right? And y equals to minus 1 plus 2t. Now combination of these two also represents the same equation, right? And this combination is called parametric equation. It also represents the same thing. If I take t as 3, for example, then we get x value as 9 minus. So if I take t as 3, then what do we get? We get x equals to 9 minus 2, which is 7, and y will be equals to 3 times 2 is 6, 6 minus 7, 5, right? So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So that will be the next point on our line. Do you see that? So that is how we can get more points, but it definitely gives you coordinates of x and y, set of points on our line, and therefore it defines the equation of the line. Perfect. Now look here. I can isolate t from these equations. So if I isolate t, then look into x. It becomes x, bringing 2 to this side means plus 2 equals to 3t, and then we can divide by 3. So we get x plus 2 divided by 3 is equals to t, right? So from the first equation, we got the value of the parameters. So from the first equation, we got this, okay? If we do the same operation on the second one, we get y plus 1 equals to 2t, or y plus 1 divided by 2 is equals to t. Now both are t's, right? So both represent t. So we could actually write this equation as x plus 2 over 3 equals to y plus 1 over 2. Now once we write this in this form, it is called symmetric equation. So we are talking still about the same line, right? It's a symmetric equation. All right? So in this you don't have any parameter, right? That's the symmetric equation. So x minus x0 divided by the direction number, y minus y0 divided by a respective direction number gives you this equation. You get an idea, right? So closely look at what I'm doing. I'm purposely going slow so that you can understand all these different forms of line. Now there's one more equation which is called scalar or Cartesian equation. Okay, let's see how to get that one. To get this equation, we can begin from here, cross multiply. So if you cross multiply, you get 2 times x plus 2 equals to 3 times y plus 1, and then apply the distributive properties. So we have 2x plus 4 equals to 3y plus 3. Bring them all to the left side. So we have 2x minus 3y, and 4 minus 3 is 1, right? Equals to 0. Do you see that? Now this equation which you get now is called the Cartesian or scalar equation. So these are different forms of your equations. Now let me just write down. Normally we had been working with the direction number, but from the scalar equation we get normal to the line. Normal to the line is this, is the vector 2 minus 3. 2 minus 3. So we get normal from the Cartesian equation, and we have this direction number. When we say normal, 2 minus 3. Let me sketch normal here to our line. 2 minus 3. So we move 2. Well, let's go from here. 1, 2 minus 3 means 1, 2, 3. That vector, right? So from here, if I'm drawing a vector in this direction, this you can see is normal to the line, right? Normal to the line. That's what I'm trying to say, okay? So this is one way to see it, right? You could have infinite number of normals on this, any vector like in parallel to this, right? So we can have, important to note, so note, we can have infinite parallel normal vectors. Okay, so we can have infinite parallel normal vectors, as all these vectors parallel to this will be normal, right? So to the line. And the way to test is, dot product of normal and the direction should be equal to 0, right? So you could do that and test yourself. 3, 2, flip it, you get 2, 3, change one sign. So that's the key to write down the normal vector, right? So that's how you do it. But anyway, in this particular video, what you have learned is kind of a summary of the whole chapter where we're discussing about equations of lines. Given a point and direction, you can write vertical equation, point plus parameter times direction, where parameter can take any real value. Now if you write x and y separately, you get parametric equation. If you isolate t and equate the two, you get symmetric equation, which is right there. And if you cross multiply and write down as a standard form which you have learned earlier, it is called scalar or Cartesian equation. From scalar or Cartesian equation, we can always read the normal. Okay, so this is what we have learned in this video. I'm Anil Kumar, and I hope that helps. You can always share and subscribe to my videos. Thank you, and all the best.